8.4, properties of rhombuses, rectangles, and squares. Central question, what are the properties of a parallelogram that have all sides or all angles congruent? We will be using biconditional statements. Biconditional statements are very common for very strong statements made in terms of, in this case, parallelograms. Biconditional statement is a two-way statement. It's also known as an if and only if. If and only if. Statement. Alrighty. The if and only if will replace the original statement and its converse. So it's kind of a shortcut. Next, we're going to deal with some corollaries. Corollaries are kind of cross between definitions and theorems. So a corollary for a rhombus, called the rhombus corollary. A rhombus corollary says a quadrilateral is a rhombus if and only if it has four congruent sides. Yeah, rhombus, also known as a diamond, would look like that. All right. Rectangle corollary. We'll say a quadrilateral is a rectangle if and only if it has four congruent angles. Now in this case, congruent will also mean right angles. The square corollary is just saying that a quadrilateral will be a square if and only if it is a rhombus and at the same time a rectangle. So a quadrilateral is a square if and only if it's a rhombus and a rectangle. So a square has the rhombus parts and it's got the four right angle parts. A rectangle has congruent angles or four right angles. Sometimes squares are referred to by geometry people as rhombtangles or rectibuses. A1 here, name each quadrilateral for which the statement is true. So we have parallelogram, rhombus, rectangle, and square. It's equilateral, rhombus, square. Diagonals are not congruent. Parallelogram would be the only one. Can contain obtuse angles, while a rhombus can, and a parallelogram can. Has no acute angles. A rectangle has 4 right angles, and as does a square. 4 angles are congruent. Rectangle and square. Both sets of sides are parallel. Well, it's going to be all 4 so far. Parallelogram, rhombus, rectangle, and square. So those are answers to our first page. Second page here, let's have some theorems here. All right. A parallelogram is a rhombus if and only if its diagonals are, and again, an if and only if is a biconditional, perpendicular, which means they form a right angle. So again, a rhombus, also known as a diamond shaped. I got this, 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 and this. Diagonal 1, diagonal 2, perpendicular. Opens up a whole lot of possibilities with right triangles. Theorem 812, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Alrighty. Looking up at the previous drawing, that would mean this is congruent to that. This is congruent to that. We have doubles here and doubles here. Theorem 813. A parallelogram is a rectangle if and only if its diagonals are, in this case, we want congruent. So if we have a rectangle, that's not a rectangle yet, but now it is. This diagonal is congruent to this. It is usually shown by this type of mark. Continuing. We have some problems here pertaining to each of the 3 no figures. Find the indicated measures of the rhombus. So I'm told it's a rhombus, so I know right off the bat, I've got this going on. I've got this. I know this is congruent to this. Alrighty. So first of all, they want us to find the measure of PQT. PQT is right here. This is 30 degrees. 90 degrees, and that's going to leave this angle here to be 180 minus the 90 minus the 30. So that will give me 60 degrees. The second question is asking what is the length of PT? PT is right here. It's going to be the same as that. So that is 6 units long. So we used a couple of the properties with rhombuses. A3, find the indicated measures of the rectangle with y or WY equaling 12. Well, if this is 12, that means I've got 6 here and 6 here because of the fact that a rectangle is a parallelogram. A parallelogram diagonals bisect each other. That also means that this is congruent as well, so these are both 6. So the first question is what is the measure of WZX? WZX is going to be that angle. These are parallel, so this angle will be the same as this angle. So I will say 50 degrees. The To find xy, I want to find this. I have to go ahead now, and I know this is 90, and I know that this is 12. How can I find this missing side length? Now again, this has to be 50 right here. So now I can use 50, 12 to find this unknown piece. So that would be using cosine, so I would use the cosine of 50 degrees equals question mark over the hypotenuse 12. Okay, as I go ahead and solve this, it ends up being a normal SOHCAHTOA type problem here. I'm going to take 12 times cosine 50 and divide by 1. So to calculate that quick here, 12 times the cosine of 50, and I get about 7.7. Okay. One final problem here is find the indicated measures of the square. The square has this, right angles all over the place. Right here, if that's 5, this is 5, this is 5, and this is 5. So the first question is angle HGD. HGD. And again, this is a right isosceles triangle. So this is 45 degrees. I can put 45 degrees right here. HF. HF is right here. I already know that. That is 5. These are your notes for 8-4.